So I have the recording on, but you guys can just jump in and unmute or turn on your mic or put stuff in the chat. Yeah, yeah, TAC is awesome. As a matter of fact, our whole design hub runs on one of TAC's servers. And he's a great asset for it because he'll write us bots and stuff if we want. Maybe you write bots too. But let's take a look at this thing and talk about production. Okay. Production meets, actually, I think I'm going to make a Jamboard on this one too. So there's a way I can do a Jamboard, but it won't show up here. So I'm going to have to open a Jamboard over here and put it somewhere where you see. This is the problem with VMware, is when I'm on VMware, I can't talk with everybody else that's going on. I'll do one anyway. Where do I want to do it? You know what? I know how to do it. I can do it right from here, and then I'll there's my Jamboard. Start a new Jamboard. Okay, so you guys should all have access to a Jamboard that I just put up. Let me just make sure. Okay, so I think you can all get to the Jamboard that I just put up, and I can take a snip from here and get it onto the Jamboard. Save as week 1. And if I throw the Jamboard up over here, you'll be able to see it. So now, this is one of the things. I wish it would just do a snip, but it doesn't. Well, let's talk about it. We can just discuss it right here. So when we talk about production, we talk about a few things. We talk about form. We talk about fit. And we talk about function. And I don't care what it is, if it's mechanical, architectural, landscape, interior design, form, fit, and function are all critical. And we call that engineering intent. So those things all together create your engineering intent. And when you do a drawing, you have to be very clear. You're transmitting the engineering intent. So you can't have any like guessing. You have to be able to get to it. So most of you did indeed talk about things like units. You talked about things like materials. And materials, I'm going to include what type of material and the thickness of the material. What were some of the other things that got thought about there? Let's so as we look down here, we have the thickness, what's it made out of, what are the units, right? And so are they millimeters? And if you're doing production, this is one of the key things. I did a design at one point, and cool. Thank you. I did a design. It was for a valve, and we sent it off to China, and we got a great quote back from our. And I go, man, that's awesome. Let's get 50 of them. I was just going to get 5 to do our prototyping. Let's get 50, and they came really fast, and they were like that big because we just sent the drawings, AutoCAD, and they threw them into the machines, and their machines read 1 as a millimeter, and our AutoCAD read 1 as an inch. So we had 1/25th scale valves. And so machine tools, not just people, but machine tools have to know what your units are. And you'll see that on 3D printers a lot too. So here was some more about it. The material, the depth, those are some. Here's a really good one. What does that mean? Okay, what does that dimension actually mean? Okay, and what can I make this out of? I could make it out of a 4x4 because a 4x4 is 3.5 by 3.5. And so you could slice it and get the thickness of it. Here's another one. There's a guess that the parts are at right angles. And so that would be an interesting thing. Here's some missing views. Well, the views are only missing if it's not an even thickness. You could just say, and the whole thing is a certain thickness. But yeah, that would be really good to have. Here's a really interesting one. Finishing the material. What do you do with it? Do you sandblast it, bead blast it, paint it, texture it somehow? Do you deburr it? Things like that. How many are needed? That's sometimes on the drawing, sometimes on the work order. I'm going to show you another thing. Look at this right here. This little part. Right here. What's that radius called? Anybody know what that radius is called? Kind of important. It's called a fillet. And your fillet radius is actually important. If you could imagine if this was a piece that was supposed to fit up against this side and then fit against this side, it wouldn't go because this little corner would run into that. And so fillet radii of mating parts have to be designed. The radius also has to do with the strength of the object in what's called fatigue. So let's pretend that the engineering intent was that there would be a weld along the bottom and that this is a bracket that something's going to push, and it will cycle. Force. That's called a fatigue loading. And if you do it often enough, it could break depending on what this radius is like, or it could not break. But that's a big part of the fatigue analysis when you do your strength. So these little radiuses in the corners are important. How about this corner here? What should I know about that corner? And that corner, and that corner, and that corner. And this doesn't matter what it is. This could be part of a countertop. It could be a bracket. It could be anything. What do we know about those corners? Anybody got to? Yeah, rounded, square. Certainly, you would most likely want it to not be sharp. You would want it to be deburred, dulled, rounded, a fillet. If you cut a little square off the corner, a little angle, it's called a chamfer. So these are all things that are critical to making it. If you've done woodworking or metalworking and you've just cut this out on a saw or a mill or a Dremel or a knife, what do you know about these edges? What's the condition of all these edges and all these shapes here? Often they've got little shards on them. So they might have splinters or little sharp pieces. And to remove all those, the operation is called deburr. And so you would want to maybe deburr those things. Okay? And so now there were a lot of good questions or comments about the angle here. What about the angle that this would be at? How do we know what angle that ought to be? Because there were a couple of them up here that talked about that. Pretty much these ones are all in the same. Yeah, colors. There's some more. Part utility. What does it do? Okay, so angles. How do I know how close to perfect 90 degrees that needs to be? Have you ever tried to saw something or cut it exactly at 90 degrees? Doesn't work that way. Neither do houses. You build houses. Doesn't work that way. Have any of you ever roofed? Any roofers here? Sometimes we get roofers in. Things are just not straight in the real world. And so you would want to know how close to perfect does this need to be? And that's called a standard tolerance. Likewise up here, how close, let me get back to my Jamboard. Let me find it. So there's a bunch of other things that we need to know. We've talked about form, fit, and function. So like right here, we would have to know the radius. I'll just put R. We'd want to know the deburr. How to deburr this thing. We'd want to know about the corners. And a big thing is how close. One person said, I couldn't get it to 3.8750. And that's just because the tolerances on our mill are within 5/1000ths of an inch. It's kind of like as close as you can actually make that mill work. So you could maybe get to 3.87 or 3.88 or somewhere in between those. And is that good enough? Yeah, there's another one. Chris is saying, what's that measurement up there, right? What is that? Now, one of the things is the engineering intent has to be clear. There can be no guessing. So you could look at it and go, well, I think it's about the same, but you don't really know, right? So this measure, and the C I'm going to guess was Chris. And so that would be one. This is called the tolerance. And no matter what kind of drawing you've got, the tolerances need to be known. Now, normally in an architectural drawing, it's to the nearest 1/8 inch, and that's just sort of an architectural standard. And so you don't have to write it down all the time. You don't have to say this is 5'3" plus or minus 1/4 of an inch or 1/8 of an inch. You don't have to do that. But in mechanical drawings, you do. And in civil drawings, you have to claim it somewhere in your drawing package. Interior design, sometimes, depending on if you're trying to fit into an existing space or not. Interior designers usually use max and min instead of like a plus or minus. But everything needs a tolerance. So sometimes there's a standard tolerance, and you might have something plus or minus 1/2 degree, or plus or minus, I'm not doing that very well, 0.03 inches. And then somebody would know, oh, okay, now I know how to make that. And so this one's really interesting. What if I were to do this? What if I was to do, let's say that was 1 inch, and that would make this what? 2.875. If I put those two dimensions on there, along with that dimension, am I making things more clear, or am I making things messed up? Somebody take a guess at that. So architects do this all the time. What about for this part? Too much. Yeah, Joya, why is that too much? It is called double dimensioning.
I just think that it would be you're like for me personally, I would just look at that second one and go, "Wait, is that this one says?" I mean, I guess the math makes sense when you look at it, but once it just seems like too much looking at the screen and saying, "What does this one go to? What does that one go to?"
Yeah, and actually the math doesn't work out. And I'll show you why. So
Okay.
this one is, how long could that be? Let's say that my tolerances are plus or minus 0.03. So this could be, and I always use a calculator, 3.875 plus 0.03. That could be 3.905, right? And my part would be okay, according to this. Now, what could this be? This part could be 1.03, and this one could be 2.905, right? So if I measure using this one, it limits me to 3.905. If I measure using this and this, 3.935. And I can pretty much say that 3.905 does not equal 3.935. So now I have to go which one is right. So you had, so Joy, you had a like an innate understanding that's like, now that's there's too much going on there. Now I will say that architects do this double dimensioning all the time. And they do that because different trades read different parts of the drawings. And they want to make sure that each trade has all of the information. So this isn't always this way, but sometimes it is. So those are some of the things that I see. How do you treat the corners? How do you treat the radiuses? This dimension is definitely needed, or this dimension is definitely needed. Our tolerances are needed. The materials are needed. The units are needed. What else was on our list here? Did we, the quantity might be, what else do we have? Does anybody have another one that we're, finish? Did I write finish on here? No, the finish is needed. And that's things like, is it sanded? Is it painted? Is it washed? Oh, there's one other thing that goes along with this tolerance. Let's say you were the machinist and you made 500 of these. And you hand them over to the assembly shop or to the guys that are packaging them. What's the first thing they're going to ask? First, they're going to ask, what is it? Oops. They're going to ask for the ID of the part. What is this? Even architecture. Here's the address. Here's the roof drawing. Here's the this drawing. Here's the that drawing. Okay, so usually there's some sort of an ID that goes along with it. And then the next question they're going to ask is, anybody got a good guess? How do I know it's right? I mean, if you got one of these in a box and you opened up your Amazon box and you go, I wonder if this is the right one. Well, you'd look at the description or the ID, and then you'd look and you'd know, I wanted the one that was this big, not the one that was 4 times as big. So there's usually some sort of thing called inspection. And the inspection requirements are often on the drawing. Okay, so these are all things. So design is really cool. You're going to learn in this class kind of how to draw these lines. Oops, I don't know what I just did there. I did something with the draw order. There we go. Put this on. You're going to learn how to make this and draw these lines. You're going to learn how to put these dimensions on and make them look right so that they mean something to this. Okay? You're going to learn how to deal with all of these corners. And you're going to learn to make sure that your drawing has the right units. And so most of that has to do with, sorry about that, mostly what we're going to deal with is form. In other classes, we talk about fit and function. In this class, we deal mostly with form. But this is really cool. You guys are getting it. You're doing really, really well with it. Any other comments or questions on that one? And I really think you guys did take care of most of it here. And those of you who used this, I forgot to tell you that Control Z resets your 0. Sorry about that. Somebody in here goes, why was 0 way over here? Um, Control Z will reset your tool center 0. And so that you can operate that way. So that's cool. Okay. There we go. So that was the production one. And I wanted to take a look just real briefly at some of these drawings. So this one, you heard me chat about that. This is the central utility plant at the Academy of Sciences. It's down in basement level 1. And right over about here are the cooling towers that go from basement level 2 through basement level 1 and exit on the ground level outdoors. And you'll see all sorts of cool stuff in here. And this was a 3D drawing in Navisworks that one of our students made based on the drawing set. We've got this entire drawing set to work with. So that's kind of cool. We've got all those. And I do love this stuff. It was a very hard job. I only worked on it for one summer. I was a 3D modeler for it. And this was back in about 2004 or 5, I think. And 3D was still pretty infant. So this was a very hard job because they were really not knowing how to work with it. I think you guys saw this one is I did make a drawing of this, and I did an additional drawing. This is a really nice drawing, actually. And so that's kind of cool, and you can see them in real life. You will be able to do this. You'll actually be able to, by the time we're done with this class, if you want, you could do the majority of the piping in this building. Kind of cool. So if you're into mechatronics, that might be something you'd be interested to do. Now, it took me about 40 hours to do just the piping that you see here because the drawing plans and everything were such a mess. You could do that at the end of this class probably in 4 hours. It's amazing how much better our tools are. The tools were brutal hard to use back then. This is really nice, and this was actually used. So Shannon showed this one, and this is very, very typical. Sometimes we talk about things have to be exact and in place and perfect. Well, this is not. Okay, this is just a layout drawing, but it gets the point across beautifully, and this would be used for a planning submittal to get approval. So I'm sure that this restaurant or this cafe or whatever had to get approval to use their outdoor area, and this is exactly how you would do it. And notice they call out that there's bike parking. That meets our Cal Green Title 24 requirements. So there's all sorts of cool stuff that you add to this to show that you're meeting certain requirements, right? There's handrail requirements and planters and all sorts of cool stuff. And this is showing 6-foot distance. So you would think that somebody could be leaning back against that, and it shows a 6-foot distance. So it answers all the questions. And again, this is something that you could draw very quickly. And what you'll find, we're going to work mostly in 2D in this class, but the last week or two, if you want, you can work in 3D. You could bring all of these items in pre-built from a manufacturer or another program and load them into AutoCAD and have this done very, very quickly. So this is a really cool drawing. And look, there's where it was, right? So this is really neat, and there it is. That's so cool to be able to go, oh, God, I get it. There it is. There's bike racks. There's these little planters. There's the cabling. There's the little tables, the chairs. It's pretty neat. Here's another one that was similar to that. What would this layout look like? And can people be apart? Can they be together? You know, how would you set this up? Where is it? How much does it cost? How far apart is everybody? And then this one's really cool. And what I like about this is it shows the roof. That's what these little lines are right here. This is really nice. It's called a bubble diagram or a space plan. And so different colors mean different things. But what I like about this, and this was probably done in a program called Chief Architect. It has that look to me that this is Chief Architect. Maybe it's not. Maybe it's something else. But what I notice about this is the excellent door placements on the ridge line and the roof line. So this is it actually follows a design principle. If you look at all these doors, if this is a center point, all the doors are easily accessible at essentially a 45-degree angle from your center point. That's one of the key things about a kind of a modular, just well laid out design. And if you look about this, this is sort of, this is a mirror of this, is a mirror of this. So whoever gets to build this thing has a really good, easy thing to do. And the structure for the roof is super easy to work with. This is really easy to structure this out. So this is kind of a cool, this is really cool. Easy to treat these doors. Okay. And the other thing is you can change all these doors to a slightly different style if you wanted to. These could become pocket doors along here, along here, and along here if you wanted that type of a look and a feel. So this is a very typical small apartment or dorm, but what an excellent, nice, compact use of space this is. And I like the symmetry of it and how the roof line actually follows these. So if I were to make trusses for this, I'd have a truss landing like right there. And so I've got all this great support. And then of course, they've got a little bit of nice positive negative by being able to pull this out. Okay? And rather than having just 4 of these, they took the opportunity to put the garage in, which is really nice. So this is a really cool layout, and I just like that drawing. I like it a lot. Okay, so there we go. That's what I saw when I looked at these. Like, man, this is really nice. Could I make it? Can I make it? Look at all these little things. These are all little details that are needed to make all these. Okay, if I were to zoom in on this, I don't know if I can. You can see that it looks like this is a construct that's bracketed into place. So that's really cool. So if this is a bracket with a piece on it on a central pillar, then you just make this piece over and over and over again. And you basically just get to weld this in place, bolt it in place. I doubt if you're going to glue it in place. You could even stack these if you wanted spacers so that the load is all taken really, really well. And then all you have to do is have a little fixture that sets the angle of each one with respect to the last one. So that's kind of a cool, that's kind of a cool, um, cool drawing. And look, it's even got the footing. It's showing how the footing has to work. So there's a lot of detailed design into this. It's got the rails that are needed on the upper side. I did do, let me see if I've got this. Spiral. No, I did a full spiral layout just to prepare. I'm going to show you how you can make these, how you can get this all in here really quick and then make this long rail. But it looks like even the rail might be made out of pieces with a special fitting. But this is a full, nice detail. It's got a bill of materials. This is just really cool. It's got sections so that you can see where you're looking. Just a cool drawing. I like it. Okay, so that's what I wanted to point out from these. Um, really interesting stuff. Does anybody have any comments or questions about those? This one was Joya's, right? Yeah. It is very cool. You'll be able to do this by the time we're done, Joya. Okay, well, I'm going to go ahead and turn off